XGBoost parameters. Part A. Let's understand the XGBoost parameters. General parameters consist of a number of threats that help to prepare data. Task parameters correspond to the objective that helps to build a model. Evaluation metrics help to predict and visualize the predicted values. Booster parameters consist of a step size that evaluates the prediction performance metrics and ROC curve and regularization that compares the prediction performance against the logistic regression model. Let's understand the general parameters of XGBoost. General parameters guide the overall functioning of XGBoost. So let's understand what these general parameters are. nThread is used to define the number of parallel threads we are going to use. If no value is entered, the algorithm automatically detects the number of cores and runs a thread on all the cores. Booster parameters guide the individual tree or regression at each step. There are two types of boosters. Which booster can you use? GBtree uses tree-based model. GPLinear uses linear function. Usually, a tree booster outperforms the linear booster. Silent default equals 0 is used to print the running messages. If the silent parameter is set to 1, no running messages will be printed. Hence, keep it 0, as the messages might help in understanding the model. Let's look at the booster parameters. Booster parameters give the individual booster tree regression at each step. Let's look at the parameters for tree booster first. ETA defines the step size shrinkage used in update to prevent overfitting. After each boosting step, you can directly get the weights of new features, and ETA shrinks the feature weights to make the boosting process more conservative. ETA range is between 0 and 1, and the default value is 0.3. Gamma defines the minimal loss reduction required to make a further partition on a leaf node of the tree. The algorithm will be more conservative when the gamma is larger. Its value ranges from 0 to infinity, and the default value is 0. Max depth is used to define the maximum depth of a tree. Its value ranges from 1 to infinity, and the default value is 6. Min child weight is used to define the minimum sum of instance weight needed in a child. If the tree partition step results in a leaf node with the sum of instance weight less than min child weight, then the building process will give up further partitioning. In linear regression task, this simply corresponds to the minimum number of instances needed in each node. The algorithm will be more conservative if the min child weight is larger. It ranges from 0 to infinity, and the default value is 1. XGBoost parameters. Part B. Max delta step is used to set the maximum delta step allowed in each tree's weight estimation. If the value is set to 0, it means there is no constraint. If it is set to a positive value, it can help make the update step more conservative. Usually, this parameter is not needed, but it might help in logistic regression when the class is extremely imbalanced. Its value ranges from 0 to infinity, and the default value is 0. Subsample is used to calculate the subsample ratio of the training instance. Its value ranges between 0 and 1. And the default value is 1. Call sample by tree is the subsample of ratio of columns when constructing each tree. Subsampling occurs once for every tree constructed. Its value ranges between 0 and 1, and the default value is 1. Now let's understand the parameters for linear booster. Lambda defines the ridge regression regularization term on weights. Increasing this value will make the model more conservative. The default value is 0. Alpha defines the lasso regression regularization term on weights. Increasing this value will make the model more conservative. The default value is 0. Lambda bias defines the ridge regression regularization term on bias. Increasing this value will make the model more conservative. The default value is 0. Now let's look at the task parameters. Task parameters guide the optimization objective to be calculated at each step. The objective options are binary logistic, defines logistic regression for binary classification whose output is probability, not class. Multi-softmax defines the multi-class classification using softmax objective. Evaluation metrics for validation data. A default metric will be assigned according to the objective RMSE for regression, error for classification, and mean average precision for ranking. The evaluation metric options are RMSE, log loss, error, AUC, mirror, MLO gloss. Demo Pima Indians diabetes. Problem statement. The objective of the dataset is to diagnostically predict whether or not a patient has diabetes